Thanks everybody for joining us on CodeChat. My name is Jeremy Foster, and you can find me online at codefoster.com or on Twitter at codefoster. And the URL for CodeChat, in case you don't already know, is codefoster.com/CodeChat. If you go to /feed after that, you'll get the RSS feed. And I have an audio-only RSS feed at /audio. So /CodeChat, /feed, /audio. It's a lot of slashes. You got it? Excellent. So that's CodeChat, and you guys know me, but you don't know Frank. Say hello to Frank. How do I say your last name? Is it Krueger?
Just Krueger.
Krueger.
Easy peasy.
Easy peasy, Frank Krueger.
Yes.
This is Frank Krueger. I met Frank at a local meetup in town, a meetup that tends to talk a lot about Xamarin, and you talk a lot about Xamarin, right?
.NET mobile developers, technically. We're keeping it open to everyone. We don't want to be exclusive or anything like that, so everyone's welcome.
But you can hardly help it when you've got a cool technology like Xamarin, right?
Yeah, it's
Oh, you
cool.
want to wake your computer up there? We went
Oh my
totally
God.
dark.
Oh my God, laptops.
Do you have it set for like 60 seconds? Whatever.
You act like I know how computers work.
Well, I decided to bring Frank on the show because I was at a recent meetup for Seattle.net, mobile.net.
Got it.
SeattleMobile.net. And Frank had this slick robot running around the room. He was controlling it with his phone. And we've all seen stuff like this before. In fact, I have one of these. But I bought mine in a box.
Oh, cheater.
I didn't make it from scratch.
Definitely cheating.
So this is super geeky, super cool. We tend to talk about geeky, cool things on this show. So
Awesome. Yeah. Well, it's not fully from scratch. Technically, we bought a $12 little wheeled robot, and then I've just put
That's
a mess
scratch.
of wires on it.
That's scratch. You
Okay.
can buy the wheels. It's still
Yeah,
scratch.
I just didn't want to 3D print the
You don't
wheels.
have to like
I'm kind of
carve-
lazy.
Yeah. Carve them out of stone.
Something like that. Yeah, or cut out the plexo. Yeah.
Okay, can you give us a little bit of a hardware overview of this bad boy?
Yeah, absolutely. Actually, the most important part of this guy is the Netduino sitting here. And do you know anything about a Netduino?
Not enough. Why don't you just pretend I know nothing and
okay.
talk about it?
Well, have you heard of an Arduino?
Yeah, sounds really familiar.
Okay. So there's this thing called Arduino, and it's great for the maker community to do small robotics. The problem with the Arduino is it's a pretty small processor, and you're forced to use kind of a C language. It's C++, but everyone programs in a terrible C style. And as a .NET developer, and they have a terrible IDE. So as a .NET developer, well, we're all kind of spoiled. I wanted a garbage collector. I wanted easier, a better programming language, so we have C#, and we can program this thing from Visual Studio. So you get all the advantages of .NET, but you also have compatibility with the Arduino. So we have everything that has been created in the Arduino community, Netduino users can use.
Excellent.
Yeah.
All the code or the hardware or both?
Hardware.
Okay.
I mean, you can translate the code from C to C#,
Yeah.
but it's usually better to rewrite it because
Yeah, right.
it's C. So this robot, he just has a few little sensors on him. Obviously, actually, I should begin with, he has 2 wheels. Very important.
3 wheels.
Yeah, the third wheel's not so hot. It comes and goes as I lose parts, but it's a 2-motored robot.
Okay.
Yeah, and we start with the 2 motors, but then that's pretty boring because otherwise you can just create a car that drives around and nothing happens. So with this guy, let me actually unplug him. We also added 2 little eyes to him. These are infrared range finders.
Okay.
And that's all to turn him into basically a cheap Roomba.
Okay.
So he can just move about a room, bounce off the walls, that kind of stuff. And then we get really fancy. And we add another little board. This is actually a Bluetooth LE board, a Bluetooth low energy board. And we do that so that we can communicate with the robot using phones.
Okay.
Windows Phone, iOS, Android, all those kinds of things.
Excellent.
So we have a platform, and we just keep adding junk to it, more and more wires, until it's terrible looking.
Okay. Now, is this what you would call the Internet of Things?
Internet of Things. What is that? No, I've heard that term before. I think I last heard that term about 10 years ago. So I really don't know how to attack that. I think of all this as just the maker community coming together. There's been the whole, I guess it started with the Make magazine and everyone just starting to build a community around it, with the 3D printers especially.
Yeah.
And then obviously Arduino. It's just a small community. It's a huge community. What am I saying? It's a small set of tools that a huge community can use, and the variety and, I don't know, creative effort coming out of it has just been awesome for the last...
It's inspiring, isn't it?
What, like 4 years? We've had just awesome stuff coming out of the community.
Yeah.
We have full engineers that love to just tinker because, you know, you work at your job and you work at Boeing or something and you work on the tiniest little cog of a giant airplane. Or you can come home and build a robot and start doing crazy things in your house and wiring up your house in different ways.
Did you see the car recently in the news that is entirely 3D printed?
No. A car?
Where have you been? On a mountain?
In fact, I have been on a mountain.
Do you want to tell the crowd where you just were the last couple of weeks?
Well, about 2 hours ago, I was at the airport. About 10 hours before that, I was in Paris. And about a week before that, I was up on Mount Kilimanjaro in Tanzania. Just on a little vacation that was not very relaxing. And kind of stressful, in fact.
Yeah, no kidding.
But somehow made it up a mountain.
Excellent.
And so I'm a little out of touch with the world, but I'm catching up. Catching up
Awesome.
quickly.
Awesome, yeah. You'll settle back in.
Somehow.
Okay, so maker movement. We're talking about making this stuff, and you gave us a little introduction to the hardware that's involved in this robot. Can you give us a little demo to it and then show us what software you have running on this? Because that's the real magic of it, right?
Sure. So this robot's actually not even in autonomous mode right now.
Okay.
Because the last thing I was working on with this library was this communications with him.
Okay.
So I've actually turned him into a bit of an RC car.
All right.
And your iPhone, or whatever your phone is...
Now, should I block it? Is he going to run off the table?
Most likely. So prepare yourself.
Okay.
It's going to take me a second to boot this up because I didn't prepare.
Okay.
We can't see this one, unfortunately. So there's no sense in talking about this.
That's fine.
But I have a little app on my phone that's right now getting data from the robot. It's a two-way communication.
Okay.
So right now the robot's telling me that he's just sitting there doing nothing. It's quite boring.
So it is 2A. It's got a little bit of...
Yep. And I can control the robot using gestures on the phone. So if
Okay.
I hold my phone up perfectly perpendicular, he's stopped.
All right.
If I start to pitch the phone down a little bit, he starts to want to move.
Okay.
And I can rotate the phone around to turn him left.
Ah.
I can turn him right. And I can pull him back a little more again.
Rein him in.
And then attempt to go straight forward. Come on, little guy. Okay, he doesn't want to go straight today. So the joke of this is I got the messaging I wrote a messaging library to communicate between the phone and the robot. And in classic hacker fashion, the moment I got it working, I was happy and I said commit and I said I'm done. I didn't take like an extra 15 minutes to really tune the controls. So he's actually kind of hard to use. But with a little practice, you can figure him out.
Yeah, yeah.
Or he'll go crashing off of a desk.
Okay, now the eyes are used whenever he's in autonomous mode, though?
Yeah, exactly. Okay. And we're creating a little library called Xamarin Robotics, and there's just a few little examples or templates, whatever you want to work from.
Yeah.
And one of those templates is a Roomba, basically, just bouncing off of walls, doing his thing. It's actually kind of fun to watch him.
Yeah, really.
My real goal is to combine the two so that he's bouncing off of walls, but then you can pick up your phone and actually command him to do things. I want him in that split mode.
So it'll just kind of always override whatever
that's exactly what I want.
He has.
It would have probably taken an additional 10 minutes that I just didn't have. I had some Star Trek to watch or something.
Yeah. Something more important.
Yeah, it's tough, you know. So to prevent him from going off the table, I'm just going to pop out the battery for a
set
moment.
Your phone down. Good idea. This is neat. It's actually really simple. I mean, we've got two sensors, one brain, and a communication device, and then just a little bit of a hardware driver, an H-bridge for the motors, right?
Yep. Everyone knows what an H-bridge is, right? Oh, gnarly.
That will plague us.
Yeah.
Okay, so that's fine. That's the hardware. What about the software? You told us you're working on a Xamarin Robotics library.
Xamarin Robotics, yep. Working with a gentleman, Brian Kostenich from Xamarin.
Okay.
I don't actually work for Xamarin or anything like that. I'm just a big fan.
You just love their stuff.
Yeah, I've been using it for so many years that I think they called me a mascot at one point, and I kind of enjoy that title. So
that's nice.
I'll
the
stick
Xamarin
with that
mascot.
one. Yeah, I'm the Xamarin mascot. So there's a gentleman at Xamarin named Brian, and he's enthusiastic about robots along with me.
Yeah.
And we both just said, well, NetDuino's nice, but we want something a little higher level. We want something to make making robots to be easier. And so we decided to create a library.
Okay.
And he was kind of crazy and let me just go off on my own and design it myself. And so I built a little library that can interface with a bunch of different sensors. We're always adding more sensors to it. Always, you can always keep adding, right?
Yeah.
But basically, it's a very simple way to piece together a robot by components.
Yeah.
So I simply say, I have a motor, I have a motor. I actually just in code tell them to connect to each other. And that's about it. You can get a very simple reactive robot, the one, say, bouncing off of the wall, with about 8 lines of code. No logic at all. You're just hardwiring. All I do is say, the proximity of the right-hand sensor drives the speed of the left-hand motor. The proximity of the left-hand sensor drives the speed of the right-hand motor. And that's pretty much all you need to bounce off of walls.
So that means that when I get something on my left-hand side,
if I said those right, I might have crossed the wires or crossed the streams, but
okay, but you're just basically getting it to turn away from walls, right?
yeah.
Okay.
And we call that reactive design.
Yeah.
In
So you don't
control
have to
theory.
be so imperative about it. Like, if this is close, then do this, then do, you know.
It's not like an event. And
Yeah.
if this,
Sure.
yeah, it's the if statement. You really want to move away from if
Sounds like you're
statements.
thinking functionally.
Yeah, and all those reactive frameworks for like doing user interfaces that
Yeah.
are really popular right
Yeah.
now. Reactive works for everything.
Yeah.
Yeah, so I
Yeah.
won't say functional. I'd say reactive.
Reactive, yeah. Well, in my opinion, hopefully I'm right on this, you'd correct me if I'm wrong, reactive is like an application of functional. Does that sound right?
You can do reactive in an imperative style also. That's the
okay.
only reason I'm being very
see.
hesitant. The first software I wrote was embedded software on an 8052 microcontroller in assembly doing reactive programming.
Okay, wow.
So it was as imperative gets.
Yeah, yeah.
Functional certainly makes it easier.
Now,
and
do you have
cleaner.
a core library for reactive stuff?
Yes, but reactive itself is very simple. Like if you look in .NET, the iObservable interface, there's like one function on it or
Yeah,
something like
right.
that. You don't need much. You say subscribe and start giving me data.
Yeah.
And so yes, we do have that core, but I feel bad even calling it a core because it's literally just an interface function and everything has to feed
Right.
into it.
Do you use any of the reactive extensions library features?
No, we don't. Unfortunately, as much as the NetDuino is awesome in all of its ways, except for one, the micro framework that it uses Microsoft's micro framework.
Yeah.
It doesn't support generics.
Oh, wow. Okay.
Yeah, and it turns out a lot of people write code using generics these
Like
days.
RX.
Yeah. So we had to build up from scratch.
Okay.
But that's fine too,
Yeah.
because I wanted to be very sensitive around threading, things like that. Some parts of it need to be thread safe, other parts don't. Yeah, little tricks, but also I have a terrible reputation for not invented here, and so I'm just perpetuating
For what?
that myth. NIH, not invented here.
I'm not familiar.
Oh, I tend to recreate everything that I see.
Yeah, I do that too.
Reinvent the wheel. I improve the wheel every time.
Reinvent and improve?
Yes.
Yeah, me too.
It's my shtick.
Hey, let's take a look at this. Let's take a look
Okay.
at the first of all, the robotics library that you're talking about, and then what it is that drives this little guy. Does he have a name? I feel bad just calling him like this guy.
Yeah, that sounds like a good name, Guy. I just came from France. Guy? I don't know.
That would work. Home?
No, I call him two-wheeled robot.
Okay.
Because I'm a
That's
programmer
good.
and
Yeah.
very non-creative. So the whole idea around the Xamarin Robotics library is that it's a block-based data flow library. So the idea is if I have two sensors, I have two blocks, a left sensor and a right sensor block. And then I connect ports on the block. So there's a real physical analogy with how the software is created.
Okay.
You can really think of it as, two ICs, two things that you're plugging in and using a wire to connect them. And that's exactly how you write the software.
Yeah.
So that analogy just carries through.
Great.
And that's why you see here with this two-wheeled robot, he inherits from this thing called the block base.
Okay.
And honestly, the block is very light. This block base is implementation inheritance.
What does it give you?
Nothing. I mean, a name, because we have a lot of debugging features.
Yeah.
That's the other thing. Like, everyone's always doing their own printf style debugging, and so a big part of this library also is making debugging easier, especially with reactive systems. When you just have a lot of data flowing around, it's really hard to understand what's really going on.
Yeah.
Especially robotics, because you don't want to hit stop on a debugger, because then nothing's happening and you can't really diagnose everything.
Yeah.
You want a continuous flow of data feeding into something that you can interpret.
So where does that debug data go? Into a log file, or?
We have multiple
Providers.
Yeah, providers. Yes, abstract.
again.
I mean, this is .NET programming. Jeez. Use an interface. So we have a console logger.
Okay.
We have one that dumps data over our messaging protocol.
Okay.
Over Bluetooth or any stream-based thing. And yeah, that's about it. I mean, the library is in its beginning evolutionary stages. This is version 1.
Yeah.
But it's an interface.
Is it released?
It's going to be... Depends on when you release this. So this is what, like Monday? What are we up to?
Well, it's
Monday the 29th. So
we're going to be in about a week from, I think, when we're recording this is when it'll go live.
It's most likely going to be released by the time this video's out.
Okay, good.
Yeah, we're just finishing up some documentation because it turns out people can't read my mind. I do my best. I put comments in, but they still say no.
Where do folks go to find it?
We have it on GitHub right now under Xamarin.
I'll put a link on the bottom of the screen.
Yeah,
so.
okay. I'll have to find that for you, to be honest, too.
No problem.
Righto. So again...
So what are we looking at here? This is the robotics library itself?
No, this is actually the implementation of this little robot here.
All right.
And in fact, it's the very simplest version of it, just the 2-motor version. And I just thought it was a good place to start because it shows how the API works from a very high level.
Okay, excellent.
Yeah, so we have a block here. And this block actually has a few dependencies. It needs a left motor and a right motor. So we abstracted out the motor control itself also, because we do have just a little $1 chip doing this. But if you want to splurge and spend $15, the maker community, we try to keep it below 10. If you want to splurge, though, there are much better control boards that you can get, so you don't have to have this beehive or nest of wires here.
Spaghetti.
Or, and that's really my fault. Take more time, you can do a nicer job. But
you can braid them or something, huh?
Yeah, actually, I braided
Yeah,
this
look at that one. Looks braided. Yeah, that's good.
Yeah. So we had to abstract because, again, it's .NET. It's a requirement. And then it also had some utility here to abstract out.
Good.
So we have this little 2-wheeled robot, and he's quite simple. He has a couple inputs, a speed to go, a direction to go.
Okay.
And the direction simply speeds up one motor over the other, so it drives it in one direction.
So is it like a direction delta, like 5 degrees to the left, or is it an absolute direction, like 187 degrees?
It's a number -1 to +1.
Oh,
-1 is full left, +1 is full right,
Gotcha.
0 is attempt to go straight. If you're not using very cheap motors, it probably would go straight, but there's a little tuning to actually make it go straight.
Your 0 case is broken.
Yeah, 0's tricky, And then he has actually one more, see, it is a he. I do refer to it, Okay. One more input, spin, because if you have a 2-wheeled robot, you have to absolutely make him spin in place.
Yeah.
It's a requirement.
It's a requirement. Just for the cool effect.
And then the this guy's a little high level, so the code does a variety of things. But it usually boils down to very simple statements like this. Here's a left motor. The left motor itself has a speed input, and I just start throwing values into it.
Okay.
That's the reactive part. I just start assigning values, and they propagate throughout this mess of wires and hardware wires and software wires.
Yeah.
And it all gets distributed.
Okay.
But then if you actually want to see how some things work, we just have a variety of sensors, motors. We have signal generators, well, very simple ones, constants, a sine wave. We have a software PWM.
And what might I use one of those generators for?
A lot of times, just testing. Like, say I created this robot, and I want him to go forward for 5 seconds, pause, go forward for 5 seconds, pause. Well, in signal theory, that's a square wave.
Yeah.
Just do that.
Yep.
So why not just call it a square wave.
Sure.
I don't actually have one. I have a sine wave. Bad example. Or version 1. So the idea is that instead of imperatively programming like a time-based update cycle like you would do for a game, like
Sure.
an X and A game, where 60 times a second you have to update some values. Instead, we take a high-level constructive approach and just attach a sine wave into the speed input.
Really cool, because
then
then the
he just does
developer
it.
can imagine, I mean, he can visualize it.
It's a higher level of thinking, and it's
Yeah.
more productive
Yeah.
because you don't want to mess. Honestly, the robotics are hard enough with all these wires and
Sure.
shortcuts, all the shortcuts we take. You want the software to be very simple. You want it to be very readable.
That's the problem with imperative coding, is that it gets you down into this place where you're like, wait a minute, where was I? What does that value mean?
Yeah.
And what do I have to do to this? And what time are we
And
in?
you start creating state machines. You start
Yeah,
saying,
right.
okay, for t less than 5 seconds, do this. For t greater than 5 seconds, do this.
Yeah.
Oh, it just starts boiling your mind. And
Right.
then you can't compose things together.
Sure.
So this is very composition heavy.
Yeah.
It's built on composition and is built to allow composition.
Yeah, to facilitate it.
Facilitate it, yeah.
Great.
And so that's how all these work. So we have these generators that do just what we were describing. Then we have some specific controllers, like we have this Adafruit motor controller. And they all, well, it's hard to see exactly, but they all are just based on this block metaphor.
Yeah. Yeah.
So that's very simple. And then we have a bunch of sensors also that I've been slowly adding and programming. We just have a couple of each one, basically just working our way through
Yeah.
sets of sensors. We're doing a
Do you
pretty
have other
good
contributors
job.
on the project?
Yeah.
Excellent.
So far it's been mostly me just because everyone thinks I have free time.
Yeah.
And so they
Weird.
stick me with it. Yeah, I don't know.
Shouldn't be so productive.
Oh, it's frustrating. It's a really hard life.
Yeah.
But as you can see, it's not the hardest things to program. This is the entire source code to read. I believe it's an accelerometer. No, it's a temperature sensor.
Okay, great.
But I mean, we're talking what?
So nice
like-
that all that is abstracted away from me. You know, when you're actually
Yeah.
writing the program, that's
You
the
don't
type
care.
of stuff that should be abstracted away.
And the stuff that you actually care about is it has one reactive output.
Yeah.
Temperature.
Yeah. What is the temperature? Thank
Yeah.
you.
And I've
right.
even gotten a tiny bit crazy where we actually have units too.
Oh, interesting.
So that in the debugging, in your debugger, it'll tell you this is a Boolean, this is a distance, this is a frequency, because you oftentimes with robotic stuff, you start like, oh, okay, this function takes kilohertz, this function takes hertz. And you start forgetting which one takes which, and this one takes seconds, this one takes milliseconds. And so units are important.
Yeah.
We even have funny units like Gauss because we have a magnometer sensor. Fun things like that.
Now this, I imagine, library is inherently capable, excuse me, of working on any platform, right? Because it's using Xamarin.
Yeah, and it's not even that it's using Xamarin. It's using it's almost a .NET 1.1.
Okay.
So anything that can run old .NET can run this library.
Just a
And
lot.
we've been very strict about keeping it that way. So I actually run all my unit tests in Visual Studio.
And it's not literally .NET 1, is it?
It's a mixture because I'm
Okay.
using C#5
Okay.
compiling down to like 1.1 code.
Okay.
Because I like C#5.
Okay.
I like var and
Yeah.
a few other things.
Yeah.
Yeah. Right. So I'm even able to run unit tests. So while I'm working on a sensor, I can write the driver for the sensor and write unit tests around it, all within Visual Studio. It's kind of like a framework that's built for mocking also, because it's
Yeah.
all composition-based.
Yeah, right.
Mocking is super easy also.
Yeah. Because you can just put in test feeds and then analyze
Just throw a
test
sine
outputs.
wave into it, throw whatever you need to throw into
Yeah.
it, and just
Yeah.
test it that
And
way.
then you're confident that when you finally send the program down to the NetDuino, because that's the workflow, right?
Yeah.
You work on it with your test suite, and then you pass it down to the NetDuino, and then you watch. You're pretty confident
it's
that
going to work. It's
Yeah.
100% guaranteed. It'll do
guaranteed to
exactly
work.
what you want. I've had to pull out the oscilloscope maybe 4 times.
See, I don't even own my own oscilloscope yet. I really feel like I need to get one of those.
Well, I'm doing the heavy lifting for
Yeah,
you.
there you go. Maybe I'll just download the library, huh?
Yeah, I think they might have an oscilloscope app for the phone.
There you go.
Use your, yeah.
What else do you want to show us with the software that's running on this?
Well, the other part of it, the part that I'm actually most proud, I'm proud of a bunch of parts of it.
As well you should be.
The part that I worked on last is the communication protocol.
Okay.
Because we wanted to be able to control these things from phones. And the problem with phones are that you either need Wi-Fi, which is great. Wi-Fi, solves all problems, except Wi-Fi is expensive.
Mm-hmm.
We're trying to keep things at the $10 range,
Mm-hmm.
and right now these boards just don't have Wi-Fi.
Mm-hmm.
But what they do have is Bluetooth, and specifically Bluetooth LE.
Mm-hmm.
The thing is, Bluetooth LE, it's not the most programmer-friendly thing on the planet.
Okay.
It's conceptually very simple. Bluetooth devices have services and characteristics, which are basically just values that are constantly transmitted. But it's not like a TCP stream. It's not like a file stream. I can't just send long bits of data and get long bits of data back. It's just not designed to work that way. But that's why we have abstraction, and so and we built a stream library to go on top of that. A stream library that's specifically designed. It's almost like an imperative, declarative switch that it has to do to make all that work. And then on top of that, we just built a very simple messaging library for communicating variables. So this guy transmits his variable set. So when it comes up on my phone, any robot I connect to, he just sends his variables and it just comes up automatically.
Whatever he wants, whatever they want to be for that particular robot?
Yep, and the idea is very simple. You have your block diagram conceptually in software to build this robot, and any of those ports, you just say, make this a global variable that gets transmitted over the protocol.
Okay.
And then very simply, the phone or whatever can monitor those variables and set those variables. So it does that very well. Brian has a requirement, Brian Kostanich again. He really wants to do video over it, so we're trying to... we don't quite have the bandwidth for video yet, but it's been very stickler in our mind that we actually want streaming data, long-running data, so maybe microphone data or things like that. Streams. You want really streamed, long-running data. So I'm pretty happy with how that turned out. Enough that I'm able to do a little remote control robot with them.
Yeah, that's just really a showcase of all the stuff that we know is going on.
Exactly,
Take a look at the library.
We're trying to release a bunch of examples just to get people's minds going. But all the examples are super simple, so we're hoping that people will just take them and mess around with them.
Yeah. Excellent. Man, that's a great robot. Great code. Folks know where they can go get the code. Where do they find components if they want to start building something like this? Where do you buy yours?
The maker revolution has succeeded. There are a lot of robotics websites. Should I give actual names?
Yeah, sure.
Okay.
Go for it.
The one I prefer is SparkFun. It's a website, sparkfun.com. They're out of so many companies. I feel really bad naming any, to be honest.
Okay.
But just go to Google with Bing and type robot parts. And the first 10 entries will just be an assortment of sensors and other crazy things you can put on there.
So we're okay if we don't have a Radio Shack just down the road from us. We can
they were
just
all
order
closing.
everything on. I think so.
Yeah, Radio Shack works fine, actually. Yeah, there are a bunch there, but the internet solves all problems.
Yeah.
They're even on, even Amazon has robot parts these days. It's just such a big movement that everyone's got it.
Yeah. Have you gotten into using 3D printers for augmenting this?
Totally. Yeah, and in fact, I'm going to Xamarin Evolve next week, and my goal is to clean this guy up and make him look like a proper little robot. Yeah.
He looks pretty proper to me, but
he looks terrible. So I want to clean him up. I'm going to build a nice little chassis to hold things and clean up all the wiring. Yeah, so my personal stake in all this is I like legged robots, walking robots.
Interesting, yeah.
Oh, jeez, again. And so what I like to do at home is print bones, attach servos to be like a knee joint, hip joint. So I'm into the legged stuff.
Okay.
Problem is that stuff's hard.
Sure.
So this is an easy demo. Sometimes he falls off tables, but otherwise he's easy.
Yeah.
Legs are hard. Getting a good stride, getting that kind of stuff. But that's what I'm interested in.
Fluid movement, I'm sure. There's kind of a lot.
Very difficult.
Sure.
A lot of different techniques. I mean, MIT's been working on it for 30 years. There's so many different ways you can go about it. I just enjoy that part. And it's perfect for the 3D printing because I just keep building skeletons, basically.
Yeah, sure. Yeah.
Skeletons and chassis.
That's excellent. Okay, hey, well, let's go ahead and wrap up if there's not anything else that you want to add.
Oh, I can't think of anything. I feel like I've been talking and talking.
It's perfect. No, it's good. It's good stuff. It's good content. Okay, well, thank you very much for coming on the show.
Thank you so much for having me. I didn't think anyone would be interested in my dorky little robot.
I think that's not the case. I think everybody will be interested in.
Good.
Good. All right. Well, hey, thanks a lot for joining us on CodeChat. Make sure you join us next time. See you around. Whew. Boy, big couple weeks for you, huh?
Oh my God.
Mountain climbing and
I have to.